Thank you, Jay, and thanks, Jeff, wherever you went, for inviting me to do this. But as Jay mentioned, this is a project that he knows very, very well because he and I work closely together with a number of other people that we'll see in a moment on this project. But what it is, and I titled my talk, A Supply Chain Analysis of Ready-to-Use Therapeutic Foods for the Horn of Africa. Ready-to-use therapeutic foods are a treatment method for severe acute malnutrition, and clearly an issue, a health issue that strikes people and children primarily throughout the world. The way in which it's being treated currently is through a product or a product category called ready-to-use therapeutic foods. Those are largely supported by a specific product called Plumpy Nut. And so a lot of what I'll be talking about today has to do with this product Plumpy Nut. But what it is and what ready-to-use therapeutic foods are in general is basically a combination of a few different items. In this case, it's peanut butter paste, sugar, milk powder, vegetable oil, and vitamins and minerals. And it's one complete product that's used to treat severe malnutrition in children between the ages of 6 months and 5 years old. And it's a fairly revolutionary new treatment protocol for this disease. Because of the benefits that it was providing, demand, as we'll see in just a moment, was taking off significantly. And UNICEF, as the largest procurer of this product, was facing a lot of challenges within their supply chain in terms of how they went about procuring this product and some of the issues related to that. And so they put out an RFP asking for a group to come in and look at the supply chain that they were using, analyze the performance of the supply chain, and then make some recommendations for how that supply chain could be improved. And so that's what I'll be talking about today, is this project that we worked on to do just that. In terms of things that I'm going to cover today, first of all, I'll start off talking about kind of a background and overview of the project, because just how this project came about and the team that we put together to try to address this project is interesting in and of itself a little bit. And as I mentioned, the first thing that they want us to look at is how is the RUTF supply chain performing currently? And so we did an analysis of the RUTF supply chain. I want to present that information to give us some background. Then in order to understand how potential changes to the supply chain might impact the performance of the supply chain, we put together what we called a dynamic model of the supply chain. This allowed us to change key parameters and see what sort of impact that would have on the performance of the supply chain, to use that as a way to try to assess some of the benefits that we might be able to establish by changing the way the supply chain was structured, and also to use as kind of motivation and data which might help lead to the actual changes taking place. And then finally, we'll talk about the specific recommendations that we came up with. And part of that was also they asked us specifically to indicate what sort of key performance indicators or KPIs we would recommend that they track as they try to more effectively measure the ongoing performance of the supply chain for RUTF. So just to give a little bit of background, for severe acute malnutrition, the way it's traditionally or was traditionally treated was through something called therapeutic milk. This is essentially a milk-type product, usually reconstituted out of powdered milk. The specific products that were used were called F100 and F75. And what happened when a child was diagnosed with severe acute malnutrition in the traditional protocol is they essentially had to go to a therapeutic feeding center, which is really a lot like a hospital. And the reason that they needed to be admitted into this hospital, and typically the course of treatment was something on the order of 6 weeks, but in order to make this product properly, you needed to have access to safe drinking water. And the only place where that could really be guaranteed to happen in most of these third world countries where malnutrition is such a big issue is in something like a hospital setting. And also they had to make sure that it was mixed properly, that the product itself was delivered to the children properly. And so all of that required stays in the hospital feeding center, in addition to kind of forcing the child to be in this setting for a 6-week period. It typically also forced the caregiver, which in most cases was the mother, to stay with the child also. And what that meant is that the mother was not with the rest of their family back in their community, but was in this feeding center, which was largely located in the larger villages. It also exposed a child who was malnourished to begin with and therefore immunosuppressed to any other diseases which might be present within that community in the feeding center. And in general, if we look at the way that this treatment played out, malnutrition was treated with a relatively inexpensive product, the F100 and F75, but the treatment protocol itself was expensive because it required a significant stay in the feeding center. And all that changed in the last couple years with the introduction of ready-to-use therapeutic foods, or RUTF. And so now the protocol for treating malnutrition is treating it with plumpy nut, or RUTF more generally. This is labeled a community-based therapeutic approach because it allows the child with malnutrition to be treated essentially in their home, at their home community, because the advantages of RUTF and plumpy nut is that it's a product that's completely pre-packaged, pre-formulated, so it doesn't require any water to be made. It's quite stable, has a reasonably long shelf life, lasts for about 24 months from the time it's manufactured. And it's something that can be, doesn't need to have any water, doesn't need to be refrigerated, so it's easy to store as well. So typically what will happen is a child will be diagnosed with malnutrition. The mother will be given a 2-week supply of plumpy nut. They'll go back to their home, feed the child the plumpy nut over that 2-week period, and then they'll return for checkups every 2 weeks and be given the next 2-week supply. And so the course of treatment is still about 6 weeks, but now it can happen back in the home and in the village where the child lives. In general, this is a more expensive product, but the delivery mechanism is a lot less expensive because it's happening back in their home. And this protocol, this treatment protocol, was officially sanctioned in a joint statement that came out from UNICEF and the World Health Organization, the World Food Program, and the United Nations Standing Committee on Nutrition in 2007. And if we look at demand for RUTF, and this is just UNICEF demand, but UNICEF demand represents about 70 to 75% of the overall demand for the product worldwide. And if we look at what happened, we see, as one might expect, based on the benefits of the product and based on the official designation of this as the most respected protocol for treating malnutrition in 2007, is demand was increasing quite steadily up through 2007. It was at about 5,000 metric tons per year at that point in time. And at the time of the start of this project, which was in the middle of 2008, they were projecting demand for 2008 to be just a little bit under 8,000 metric tons, but to skyrocket up to about 20,000 metric tons by 2010. So from almost nothing in 2005, we see quite significant demand for this product by 2010. Yeah, John? Uh-huh. Well, yeah, I'll get into that, and I was a little bit loose of that. But these are actual orders that UNICEF places, which covers just a small portion of the true underlying need for the product, which is much, much greater. So yeah, this is just the actual orders that UNICEF is placing, based on their knowledge of the capacity for the product, their ability to deliver the product with their implementing partners who do it on the ground, the funding that's available for purchasing the product, all those other things which may make this demand much, much less than the actual need that's seen. Chirag?
For UNICEF demand, do you have any data on demand from foreign governments that also want to?
Like I said, in general, in terms of the actual orders, demand in that definition of what we mean by demand, it looks very similar to this. And this, what we see here, represents about 70% of total worldwide demand. So you just think about adding 50% to the size of these bars if you want to try to look at what the total demand was, including UNICEF and non-UNICEF demand. Now, one of the challenges, in addition to the fact that demand was rising so quickly, is that this is a product that was, plumpy nut in particular, was introduced by a company called Nutriset, and they actually have a patent, quite a broad patent, on the production of this type of product for this type of application. And it's a company located in France. Things aren't quite as bad as that might sound. You kind of think of a company holding a patent on a product like this and that being very problematic. Nutriset is not a big conglomerate, big typical corporation. It is a company that was specifically created in order to produce products to help in the battle against nutrition. And so they are willing to license the product, and there are some small local producers. But that being said, it is controlled. There's a process that one has to go through to apply for licensure, and most of the production is still taking place in their facility in Molinay, France. And so those capacity-related issues are also an important part of the story that we're going to be looking at. All right, so the specific request that came in from UNICEF was to look at the supply chain of ready-to-use therapeutic foods specifically within the Horn of Africa. And so our focus was on 3 countries, Ethiopia, Kenya, and Somalia, and looking at what that supply chain was like. Knowing that this didn't represent the entire demand by any stretch of the imagination, but this clearly was a region that was very important in the battle against malnutrition. And so it did represent a significant portion of demand. What they wanted us to do in general is examine the current supply chain, make recommendations for how that supply chain could be improved, but also kind of stepping back a bit, they wanted us to describe and articulate the process for examining a supply chain of a product like this, whether it be a nutrition-related product or a health-related product, so that they could conceivably do a similar study, a similar analysis on other products in the future. And so the kind of 3 stages of the project for UNICEF was, first of all, describing and documenting the performance of the current supply chain, then developing a model of the supply chain that we could use to assess what would happen if we changed the supply chain, and making recommendations based on both our study of the current supply chain as well as the model, which might look at how performance could be altered. And then the 3rd stage was developing this articulation guideline, which was really articulating how such a project could be performed in general. And then this guideline is something that could be used by UNICEF and also other members of the Global Nutrition Cluster, which UNICEF led, which was a co-sponsor of this project. So the team that we put together to respond to the RFP that UNICEF put out, and we eventually obviously were awarded the project, consisted of several people from UNC, so Jay and myself, PhD student Vidya Mani, who's here in the audience, current PhD student in the operations management area. And then also we ended up adding 2 MBA students to the team, Kevin Martin and Sarah Abdoulaye, who both graduated a year ago. And so that was the UNC Kenan-Flagler representation on the team. We partnered with a group from Duke's Sanford School, now used to be the Institute, but now it's the School of Public Policy, Anthony So and Karina Mushiro-Vickery. Anthony's the director of a center at the Sanford School, which looks at the global access to health and technology, and Karina worked in that center as well. And so we were the group that worked on this project. With UNICEF, we had a project director and a project coordinator, Paul Molinaro and Jürgen Holst, who are both in the UNICEF Supply Division. And UNICEF Supply Division, we'll see in a moment, is a centralized facility located in Copenhagen that's responsible for procuring and managing procurement relationships worldwide for products that UNICEF was purchasing on a global basis. And so they were the direct sponsors of the project. We got significant support also from folks within UNICEF's ASARO's East and South Africa regional office, and then also in the Kenya and Somalia country offices. So the way UNICEF's organized is they have country offices in each of the different countries in which they operate, and those country offices are really quite independent, and that's where decisions get made about programs to sponsor. Fundraising gets done quite a bit on the country basis, and purchasing is initiated on the country basis, as we'll see in a moment. We had a number of external participants. So the Kenya Ministry of Health, we had specific participants from a couple of NGO partners. So typically the way UNICEF will operate is they'll be responsible for managing the procurement of the product and delivering it within the country through the country offices. But then they'll partner locally with an NGO who's responsible for the actual determination of which children are eligible to receive the product and the actual delivery of the product to those children. And so we worked with ACF, Action contre la Faim, Action Against Hunger, with Concern and Merlin, who are 2 other international NGOs. USAID and ECHO are funding agencies in the United States and in the European Union. Nutriset is the manufacturer of the product. InstaFoods is another manufacturer of a similar type product. Kuehne+Nagel is the distribution partner, the third-party logistics partner that the supply division at UNICEF works with for the transportation of the products from Europe into Africa. And then locally, one of the Kuehne+Nagel employees in Nairobi was also part of the broader team. So to give an idea of what we looked at within the current supply chain, we kind of used some of the same models that we've talked about in class, where from a supply chain perspective, we wanted to look at the process of planning, on purchasing RUTF, procuring the RUTF, producing the RUTF, and then delivering the RUTF. And then within each of those 4 categories, we looked at specific activities within those categories and then identified who the key stakeholders amongst all these different participants were in order to interview them and get a sense for how they were practicing in the supply chain currently. And then we thought about this from the perspective of the flow of product, the flow of information, and the flow of money or funding. And as we mapped out the supply chain and looked at the different participants and the role in which they played, we saw that there were some differences depending on which country we were looking at. But for the most part, the flow was reasonably similar. So the different players we have organized across the top. So we've got a UNICEF country office, the UNICEF regional office, in this case ASARO, UNICEF supply division, which is a centralized purchasing organization, the NGO partners that UNICEF work with for the actual disbursement of the product in a specific program, the children, who are eventually the customers of the product that we're trying to get it delivered to, Ministry of Health, which at least in Kenya plays a significant role, but in Somalia, because there isn't any real government and therefore no real Ministry of Health, that they weren't a participant. The donors who are providing the funding, which allows UNICEF to purchase RUTF, the RUTF producer, in this case Nutriset, the global logistics supplier, Kenan-Flagler, and then a local logistics supplier was involved in part of the supply chain as well. And basically, as we kind of move down from top to bottom, it's roughly chronologically what's going on within this process. And so originally, NGO partners will come to UNICEF with a proposal for how they want to distribute RUTF as a method for treating malnutrition. And then UNICEF will then, through their country office and working with the Ministry of Health, determine that a program can be funded. They'll work on raising money with the donors. Once they receive that money from the donors to sponsor this particular program that they're interested in implementing, they'll issue a purchase order for RUTF, and that's something they do through the supply division. So the country office and perhaps the regional office will be involved as well. We'll ask the supply division to procure a certain quantity of RUTF for them. So it goes through supply division. Supply division then contacts Nutriset and places a specific order according to a 24-month long-term agreement that they have in place. The product itself is delivered from Nutriset in Malene to the port of Le Havre, and at that point Kenan-Flagler takes over the responsibility for delivering that product from Le Havre to the Horn of Africa. And so typically this is done via surface transportation in ships. Now, it's not usually possible, because a typical order for plumping nut will be on the order of maybe 2 or 3 shipping containers at any particular time. So obviously that doesn't fill up a whole cargo ship. So the third-party logistics provider won't have a full shipment going from Le Havre into Mombasa, which is the port in Kenya where most of this product gets delivered. So typically there'll be some transshipment point, which is most frequently Algeciras in Spain, and so the product has to get delivered to Algeciras, and then from Algeciras moves to Mombasa. So that process can take quite a bit of time for the product to physically move from France into the Horn of Africa. And then once it's there in Mombasa, if it's intended for Kenya, it needs to get delivered through the local distribution process. Somalia product gets delivered through the local logistics supplier from Mombasa to Mogadishu and then into Somalia. Ethiopia had a little bit of a different route. The problem with Ethiopia is it's landlocked, so product can go through Djibouti to get into Ethiopia, but there's a fairly lengthy customs process associated with that that could take up to 6 months. And so much of the product moving into Ethiopia ended up being flown from Paris to Addis Ababa. So that was a more expensive, but a time-compressed process. All right, as we looked at the performance of the current supply chain from a product perspective, one of the things that we wanted to look at is for each of these 3 countries, based on non-emergency orders, which were for kind of anticipated, expected, traditional treatment of malnutrition, as opposed to emergency orders, which were orders that were placed in response to a specific crisis, typically a drought or a war, conflict, some other type of unrest, which caused a specific unusual experience of malnutrition. And then kind of breaking down the lead time into several different components. We looked at the orders that were placed over the past 2 years to get a sense for how long each of the different stages in this process took. And so what each bar here represents, and the total time to deliver is up on top, the left end of the bar is the speediest delivery that we saw in the data set that we saw. And there are typically 10 to 20 orders per country that were placed within this time frame. The right side of the bar is the order that took the longest, and the break point between blue and green is where the median was. And so what the median time was. And so then we also broke it down within specific steps within the process. And so what we typically see is the kind of transportation time for the orders in Ethiopia tended to be much quicker than the orders in other countries because it was much more likely that those orders were flown. But the total time to delivery ranged from relatively quick on 10 days, but that was extremely rare, up to in some cases well over 100 days from the time an order was placed until the product arrived. And this was just arriving within the country, and then there was the final distribution within the country that had to happen after that. Another thing that we wanted to look at is what was causing any changes within the SAP system that Supply Division in Copenhagen maintained. And what we saw is that by far the most frequent cause of a change within that SAP system was an adjustment that was made to the target arrival date, or TAD. So when an order was placed, a specific target arrival date was set for when that product should arrive within the country. And it was very common for those target arrival dates to have to be adjusted. Again, typically to a later date because there was an issue with production or there was an issue with transportation. And even after making all of these adjustments, still only 25% of the orders arrived prior to that even updated target arrival date. 75% of the orders arrived after the date in which they were expected to arrive. Another thing we looked at is what happens in order volume across different months. And what you can see, the blue bars here representing the order volume month by month. And so there's quite a bit of variability from one month to another. And then the yellow line is representing for specific orders what was the total lead time that we saw. And so early on, we see quite a strong correlation as demand increases and we start reaching the limits of capacity for both production and delivery. We start to see some significant spikes in the lead time. Those are dampened a bit later on as the capacity at Nutriset was expanded. But if you look at it in more detail, and this is looking specifically at emergency orders, even then, kind of at the right end of this time frame that we were looking at, as the demand caught back up to the increase in capacity that Nutriset had in place. Again, even for these emergency orders, we started to see some significant delays on the order of 50, 60, and 70 days. Megan?
What do you think is causing the spike there in February? Is that the food crisis?
Which spike?
February 08?
Okay. Oh, yeah. Back in. This is more with the spike here is actually not demand, but in lead time.
Oh, okay.
And so, that's part of what's causing the spike in lead time is the spike in demand from hunger crises, and particularly in Ethiopia. We'll see that in a little bit. But in general, the demand was hitting capacity limits. And so when that happened, then all of a sudden, even for emergency orders which received priority, there just wasn't any capacity available to try to fill those orders. Now, one of the things that the folks that we were working with said is, yeah, I see that there's some pretty long delivery times, but there were some issues that were going on during this time frame. And so in particular, there's a lot of post-election violence in Kenya in this time frame, and they argued that that was causing the lengthy delays. And then there were port strikes in Le Havre a little bit later that they also argued were causing delays. But when we went in and we looked at specific lengths of time that it took for specific orders that were placed within this time frame, we saw that even orders that weren't affected at all by either of these two issues still had lengthy delivery times. And in particular, some of the ones that were affected by the strike and therefore had to go out of Antwerp instead of Le Havre, in some cases had even shorter delivery times. So, our argument back after looking at the data was, even absent those specific issues, there were very lengthy delivery delays that were taking place within this supply chain. From a funding perspective, if we look at how the money gets collected to pay for this product. Basically, the way things are operating now is it's a complete make-to-order environment. And so the country office assesses the need for a certain amount of product to support a program that one of their implementing partners wants to put in place, but they are not allowed to order the product through supply division from Nutriset until they have the funding available to pay for it. And so when we look at what's happening, again, this is in some ways just a repeat of the previous information, but because the demand annually is growing significantly, obviously the need for funding for purchasing this product is also growing significantly, and that puts a challenge on the fundraising efforts. And this also demonstrates the blue line is showing the overall UNICEF demand, and the green is showing just what's happening in the East and South Africa regional office. And overall, ASARO represents on the order of 50% of the total demand within all of UNICEF. And then the area that we're looking at, Kenya, Ethiopia, and Somalia, represents something on the order of 70% of the ASARO demand. So even though we're only looking at 3 countries, it is 3 countries that have a significant demand for this product. When we look at the overall cost structure and think about the implications that that has on funding, if you look at the purchase price that we pay for Plumping Nut from Nutriset and what's adding up to the cost of that, about 68% of the cost, according to a study, of Plumping Nut comes from the ingredients. And we can further break down that ingredients bar to milk powder representing 42% of the cost of ingredients, sugar 13%, vegetable oil 22%, the peanut paste 17%, and the vitamins and minerals a relatively small percent, just about 6%. Packaging is another slice, quality control, the fixed costs associated with the production equipment, and other costs represent the total ingredients and other elements of the cost of Plumping Nut. And one of the things that's been happening over a long period of time, but you clearly saw some spikes at the time of this study. This is just an example of milk powder, but it would happen in other food markets as well, is that partially because of the way corn and other products were being transferred from food products to fuel products, it caused a significant spike in global food prices across a number of different commodities, and it certainly affected milk powder as well at this point in time. Now, another funding issue is the issue related to transportation costs. And so as I mentioned, the preferred method of transportation is through surface routes, shipping the product from France into the Horn of Africa. But in some cases, either because of customs issues or if we have emergency needs for the product, they're flown from France into the Horn of Africa. If we send the product via surface transportation, freight costs represent only about 4% of the total landed cost of the product. Fully 96% of the product, or the 96% of the cost has to do with the actual purchasing of the product from Nutriset. And so on average, in the time frame that we were looking at, it costs about 17 cents per kilogram to use surface transportation to get Plumping Nut from France to the Horn of Africa. If we had to use air shipment, on the other hand, now the transportation costs themselves represent 39% of the landed cost. So on average, $2.40 per kilogram. And so what this means is if we have to use air transportation instead of surface transportation for the same funding amount of money that we have, we're going to have about 43% less product available. So it significantly cuts into how much RUTF we can buy with the same amount of money if we have to use air transportation to get it there. A couple things that were going on within the humanitarian aid sector at this point in time is there's a recognition that it was important to try to provide predictable and flexible funding. And one of the big issues that they faced is when UNICEF was putting together proposals and trying to get money for the purchase of RUTF, it was very unclear when that money would come in, which would allow them to actually purchase the product. And in general, they're also trying to provide reliable, indicative commitments of aid over a multi-year framework, because oftentimes what was happening is things were happening on a project-by-project basis, and it would be certainly a lot nicer if we had multi-year funding so that that funding availability was committed to in advance, and we didn't have to worry about it. Again, we've kind of seen pieces of this before, but if we look at a broader time period to see the monthly demand for RUTF from UNICEF, you see a general trend of demand growing over time, but you see quite a bit of variability in the orders that are placed month to month. And within any given year, the month that had the highest demand is often at least 10 times, if not more, than the month in which the lowest demand occurred. And in general, demand tends to be back-loaded towards the end of the year. Part of that's because demand is growing in general, but a lot of it has to do with funding. And because funding doesn't become available till the end of the year, it takes a while for the funding agencies to commit the money that's needed to purchase RUTF. That funding issue is part of what creates this surge in demand towards the end of each year. And that's problematic within the supply chain. If you look at the information flow within the supply chain, a couple issues, and this kind of gets back to the question originally about, well, is that demand or need? And if you look at the need for a product like RUTF, you could start by looking at, within a particular district, how many severely malnourished children are there. And based on the number of malnourished children and the amount of RUTF, which is usually something on the order of 14 kilograms, to treat a malnourished child, you could use that to understand what the need is for RUTF. Now, based on specific programs and projects that are designed within any given year, there's a certain number of severely malnourished children who will be reached by a program. And so this represents the forecasted demand for RUTF. And if there's people who are malnourished, but there isn't a program in place in order to try to reach those people, those folks represent unmet need for RUTF. And then once we have certain forecasted demand, based on funding restrictions or the availability of NGO partners to get the rest of the capacity on the ground in order to deliver the product, there's a certain amount of actual demand for RUTF that occurs, and so there may well be some unmet demand for RUTF. So when it comes from a planning perspective, and if we think about what we're trying to do more broadly in order to treat malnutrition, we need to understand that there's significant differences between what we see as actual demand versus estimated demand versus the actual need for RUTF, and those can be quite significant. And even if we're trying to get a sense for what the need is, that need determination can be quite different depending on how we're going about defining who it is that's severely malnourished and who qualifies for a program like this. So within the nutrition community, there's different distinctions between wasting and underweight. And if we look at wasting, which has to do with actual deterioration of a person's physical being, within Somalia, they estimated that 2.2% of children under 5 would be defined as severely wasted, which represents about 32,000 children. But if we're looking at severely underweight, that's going to be about 11.6% of children, or significantly more. And even if we think about severely underweight, that's measured in a number of different ways. So a lot of what that has to do with is looking at the weight to height ratio of a given child. But to decide whether somebody is severely underweight, some people will say, well, that depends on looking at, say, 3 sigma, if we do a distribution of this weight to height ratio. Other people will define it as a certain percentage of the median weight to height ratio. And so depending on how you define it, you're going to get different numbers. And so that's a challenge to trying to forecast what the actual underlying need is for a product like RUTF. A couple other things to think about is seasonality. So clearly there are hunger cycles that take place based on the natural weather patterns within different regions. So there's certain times of the year where people have a food shortage and are more likely to be malnourished. There's also transportation issues within most of these countries. They don't have very well established infrastructure for transportation. So if we've got a rainy season where most of the roads, because they're not paved, become impassable, that's something we need to take in mind as well as we're thinking about planning programs to address issues with respect to malnutrition. Thinking about young infants, this is a product that's designed for children between the age of 6 months and 5 years. If you're less than 6 months, you can't eat this paste. You're not at that stage where you're ready to. And in Somalia, severely wasted children, about 12% were under 6 months. So in forecasting need, we need to make sure that that portion of the population isn't accounted for as we think about need for RUTF. And we also have significant challenges as we think about national data versus district level data, because there's quite a bit of variation from one region to another region within a country based on who needs RUTF. And the other thing that's happening is some of the reference standards are changing. So the World Health Organization is coming out with new distributions of what typical height and weight measurements are amongst children within this region. And so as those definitions change, it's also going to impact how many people we decide are severely malnourished. And in general, most studies indicate that as these new reference standards get put in place, the number of children with severe acute malnutrition is going to go up significantly, somewhere between 1.5 times to 4 times. And that's going to have a significant impact on the overall cost of treating malnutrition in these areas. In terms of the impact of this inefficient information on the supply chain, puts stress on UNICEF because they don't have good visibility about what's happening out in the field, how many cartons of plumpy nut are still available in these field inventories, how many are being used on a daily or even weekly basis. It puts stress on the implementing partners because if they're stockouts, they're not going to be able to deliver the programs that they've put in place, or they may be able to start delivering the program, but they don't have enough plumpy nut to give to the family when they come back at the 2-week or the 4-week checkup. And it certainly puts a lot of stress on the producers because, as we all know, if we have a lot of variability in the orders that we receive, that's going to be a lot harder for us to try to deliver against than if we have a nice steady flow of orders that's evenly distributed across the year. All right, so that gives us a sense for what the picture is currently for the supply chain for our UTF. What we wanted to do is put together a model which would help us understand if we made changes to the supply chain, what sort of impact would those changes have? And so the first thing to think about is to go about deciding how we're going to assess the impact of any changes that we might want to make to a supply chain. And if we think about a traditional private sector company, that tends to be easier to do because we all know that the goal of a corporation is to make money. And so as we think about assessing performance, we can think about trying to measure profitability. But as we think about this supply chain, there's certainly no issue of profitability associated with this supply chain at all. So as we think about assessing supply chain performance, what are some things that you think we might want to consider? How do we go about deciding whether supply chain performance is good or not? What's that going to be, Jeff? All right, so lead time. Clearly one thing we want to look at from the time you place an order, country office places an order, how long does it take until that product's delivered to the country? Stephanie? So what?
Donor dollar efficiency, so maximizing the use of every.
All right, so for a certain amount of money, how much RUTF are we able to purchase for that? Yeah. Okay. All right, those are variations in delivery time across time or across different countries.
Are there any stockout situations or where you're not able to?
Okay. Yeah, how often is it that we just have unmet demand? We're just not able to produce and deliver what's needed. So all of these things end up being significant issues within the supply chain of ready-to-use therapeutic foods. So in the model that we put together, rather than developing an optimization model which said we want to figure out what's the best supply chain design in order to maximize profits, we had to do something different. We had to put together a model that would show us what's the impact of different changes in the supply chain across quite a few different dimensions. And so some of the specific dimensions that we looked at is, first of all, what's the total supply chain cost? On an annual basis, how much does it cost us to manage this supply chain within Kenya, Ethiopia, and Somalia? What's the landed cost of RUTF measured in terms of dollars per metric ton? So based on the supply chain configuration, this is kind of getting to your point about how efficient are we? How much is it costing us per metric ton? What's our average delay? We measure that in weeks, from the time an order is placed until it's received. How much unmet demand is there? How much unmet requests do we have? How many metric tons do we have in shortages in a given year? And how is that translated in terms of the impact of any unmet requests? Because we're trying to, and UNICEF wanted to be able to use this model even with donors and be able to say, all right, if we don't get the funding, this is the impact of not having that funding. And it's a lot more beneficial, or a lot more, it makes a bigger impression if you say, we've got 8,000 untreated children because of the lack of funding, than to say we've got 16,000 metric tons of unmet demand for our UTF. So translating it into the impact on children was very important. Now another thing that we had to keep in mind is that we wanted to create a tool that would be useful not just for our UTF, but would be very general, or at least fairly general in its applicability, because the Global Nutrition Cluster wanted to use this same tool potentially for other products besides our UTF, whether it be something like mosquito nets or vaccines or any other type of product which might fall into this category. And as kind of a caveat to that is it also had to be a tool that was developed and useful on a platform that most of these agencies would have some familiarity with and access to. And if we're thinking about any kind of numerical model, what that essentially means is it has to be done in Excel. And so really this kind of boiled down to creating an Excel model, not some kind of fancy simulation model or something like that, that's in a very specific simulation tool that not everybody would have access to. So it was something that had to be done in Excel. And so as we thought about designing this dynamic modeling tool, from kind of how things operate, which is on the right-hand side, versus kind of how it's implemented in the spreadsheet, which is on the left-hand side. If we start out with how it operates, what we did is we created within each country, so Somalia, Kenya, and Ethiopia, we created monthly demands over a 2-year period. So that was the starting point, is how much demand was there per month. And then within the spreadsheet itself, that was actually broken down into weekly demand buckets because we were measuring things on a weekly basis. But that was broken down just based on a certain assumption about January has 4 weeks, February has 4 weeks, March has 5 weeks, et cetera. So we started with monthly demand. We also started with monthly funding. So we assumed that there was a certain amount of money available per month within each of these 3 countries because everything's done on a decentralized country office basis. And so then the way the kind of logic of the model works is given that demand occurs, the first thing we checked is if funding's available. If funding's not available, we basically just have to wait until funding does become available, until we have enough money to actually issue the purchase order. Once that money is available, then we can release the purchase order. And what we want to check for, first of all, is where is that RUTF going to come from? And the 3 options were local production, buffer inventory, or non-local production. So local production, turns out that Nutriset has licensed the ability to produce RUTF to a few different small organizations in various parts of the world. So there's a manufacturing facility in Niger, manufacturing facility in Malawi, manufacturing facility in Congo, in the Dominican Republic, and there's also one in Ethiopia. And so we assumed that there was a certain capacity available in Ethiopia, and the model has the flexibility to assume that there's manufacturing capability in each of the specific countries in which demand occurs. And so the first thing we check for to see is if there's local production. And to the extent that there is, we'll release the capacity of that local production to meet the demand that comes locally. If there's not local production or there's not sufficient capacity within the local production, we want to check to see if there's any buffer inventory, any place where RUTF is stored. Now, in the current supply chain, there's none. They don't have any buffer inventory as part of the supply chain that they're managing. Everything's purchased on basically and produced on a make-to-order basis. But one of the issues that we wanted to be able to check is what would happen if we did introduce a buffer inventory. And so the logic of the model then checks to see if there is buffer inventory available. If that's not available, then we go to non-local production, which for the case of our model is France, but we created the tools, we'll see in a minute, general enough that you could allow for other non-local production facilities as well. And so then we'd make production decisions, either local production or non-local production. If we satisfied demand out of buffer inventory, let's say, for example, we assume that there was demand for 200 kilos of the product in Kenya. We'd ship it, if there was buffer inventory of that quantity, we'd ship 200 kilos from the buffer inventory location into Kenya, but we'd also issue a replenishment order back to the non-local production facility to replenish those 200 kilos that were demanded in Kenya. Yeah, Mohammed?
Why logically did you put local production before buffer? Why didn't you check buffer first before showing production request to local?
It just generally was felt that, because everything was happening on a weekly basis, so if there was local production capacity available, it could be used to access demand and satisfy demand very quickly. So it really didn't have a delay that was significant relative to using a buffer stock. And in many cases, as we'll see in a minute, this buffer inventory, for the most part, realistically, it would be something that was centralized. And so given that it's a centralized buffer inventory for the region, or perhaps even broader than just the Horn of Africa, it's actually a lot quicker to satisfy demand from local production than from the buffer inventory. Andrea?
Is there a way to, and maybe we'll talk about this later, but in terms of prioritizing demand, is this just a time frame, or
Yeah.
Vendors who
No,
loves children or something like that?
No, it basically it's just, it's kind of first in, first out for the most part. And so if the demand in Kenya, Ethiopia, and Somalia was twice as much as what the capacity was, then that capacity was essentially spread evenly over demand across each of those different regions. And then any unmet demand was kind of carried forward to the next week, and something that would be satisfied in the next week. And within any country, all demand is just equal. So it wasn't looked at as kind of one type or another. Aaron?
Kind of add on to that, they have the concept of emergency orders where, like, if some major disaster happens, kind of malnourishment broke out.
Yeah.
Or it just overrides everybody else.
Yeah, and in some sense, we certainly put in the capability for emergency orders, and we'll see that in a second. So there's an ability for demand to surge, and we kind of put in the capability that you'd make a decision in general about whether stuff would be shipped via surface transportation or air transportation. And so for each of those transportation modes, there was a cost of transportation and a time of transportation. And there was the ability to go in and say, if there's an emergency order, do we want to have that emergency order airshipped, regardless of what the standard transportation mode is. But in terms of, does that emergency order take the place of another order? In some sense, it almost doesn't matter with respect to the detail of this model, because let's say I had 1,000 kilos that were demanded from Ethiopia in 1 week, and then the next week I had a 3,000 kilo emergency order. Well, there's still, that means if I hadn't satisfied the original order, there's 4,000 kilos that I need to deliver to Ethiopia, and it doesn't distinguish between them. It just kind of looks to see how long does it take to get those 4,000 in. Once we kind of start shipping, then we check to see whether we completely satisfied demand. If demand's only been partially satisfied, then we go back up essentially the next week and try to satisfy the rest of demand through local production, buffer stock, non-local production. And then we check to see when that full order has arrived. So we can see what the lead time was from the time you place an order until that order gets received. And within the spreadsheet, we've got a number of different pieces of the spreadsheet. So we've got a place where we keep track of demand, a place where we keep track of the funding that's available, the capacity at each of the different sites. And the base case that we kind of use to measure the performance of the supply chain was assuming that we have a certain level of capacity in Ethiopia, which is where the facility was located, and then an additional amount of capacity in France. We assumed that everything was sent via surface transportation, and we assumed a certain level of demand. And for the base case, we assumed that the funding was always available to release an order at the time that demand was recognized. And so to just see what this model looks like. Basically what we have is for Kenya, Somalia, Ethiopia, and then total, we see what the performance is across each of these key performance measures. So what's the annual supply chain cost? What's the landed cost per metric ton? How much investment do we have in buffer inventory? In base cases, we don't have any buffer inventory. What's the average delay? And so the base case average delay in Kenya and Somalia was 8 weeks. For Ethiopia, it was only 5 weeks because Ethiopia has that local production facility which can satisfy a certain amount of demand locally, and the demand in excess of that capacity was satisfied non-locally. So they have, on average, quicker response time. And then kind of the blended weighted average across the 3 countries, based on the relative demand in each of those countries, was 6.1 weeks in this case. And here we didn't have any unmet requests for our UTF. We eventually could deliver everything that was ordered, and so therefore we didn't have any untreated children. And so it shows the performance of any given supply chain configuration, and then it shows it compared, numerically compared to the baseline if we make any changes. And then we also have a place where we show at least a couple of those key performance measures graphically. So for total supply chain cost and for average delay across each country and then in total, we can see what the performance is of the base case, and then if we make any changes to the model, we can see how those changes impact the performance of the supply chain. And so the place where all the data gets input is in a separate tab on the spreadsheet. And so we've got the ability to have up to 7 production locations, where by default the first 3 production locations are assumed to be local production facilities, and then locations 4 through 7 could be non-local production facilities. So we only use France, but potentially they were talking about authorizing a production facility in Cape Town, South Africa. There is a local, a small production facility in Malawi that could be used. They're also thinking about a possibility in Norway. We allow up to 2 different centralized warehouse locations. And so the 2 that we used in our model was one in Mombasa in Kenya, and then another one in Jebel Ali, which is in the port in Dubai. And the benefit of Dubai is, one, it's a reasonably safe environment, and you do have non-stop transportation going from any major port in Europe like Le Havre to Jebel Ali, so you don't have to worry about transshipment. And then from there, you can get reasonably quickly from Jebel Ali down to Mombasa or other ports in the region. So that was the second area that they asked us to consider. And UNICEF was in the process of creating and establishing a warehouse in Jebel Ali for some other purposes as well. So then we have cost between each of the different transportation modes. We've got time, and then cost for air transport and time for air transport. We've got the ability to indicate how we want transport to take place between any 2 nodes in the network. So 0 represents surface transportation, or 1 would represent air transportation. And then if we want emergency shipments to be sent via air, regardless of what the underlying transportation process is, we can indicate that here. Got information about the size of the buffer warehouse and how much the cost is for storing product in those locations, the handling cost for moving product in and out of any of those warehouse locations. We've got capacity levels at the different production sites that we're considering. And so Kenya, Somalia, where there aren't any production sites, that's set at 0, obviously. Ethiopia is pretty small, so it has a capacity for 35 metric tons per week. And then the other thing we had to indicate was our model is just for UNICEF demand within the Horn of Africa. So for any capacity that's available, we have to say, all right, what part of that capacity is really available to satisfy demand from UNICEF in the Horn of Africa? And so the assumption with the local producer in Ethiopia is that 75% of that capacity would be available for UNICEF. The other 25% would go to non-UNICEF customers. Within France, our assumption is that only 35% is available to satisfy demand within the Horn of Africa. And that's kind of representative of the fact that 70% of their capacity typically goes to UNICEF, and of UNICEF's demand, something on the order of half of that is represented by these 3 countries. We've got a place to indicate where we want non-local demand to come from, which of these producers, and then what's the backup producer that we might want to use. We can see what the change would be in raw material costs. So let's say, for example, milk powder doubled in price. What would be the impact of that on the overall supply chain performance? Got a place to look at monthly demand, unforecasted surges in demand. So this is where we could indicate if there was an emergency, how big is the increase in demand? Is it 50% of normal demand or 100% of normal demand? How quickly do we jump up to that new level of demand? How long do we stay at that new level of demand? And then how quickly do we come back down to regular levels of demand? Measure of per patient use of RUTF, and it turned out the assumptions were different in different countries based on the protocols that were in place in those different countries, and then monthly funding levels as well. And then an indication to assume, do we assume that funding's always available, so don't delay the release of orders until funding's been received, or do we check the money and make sure we have the money available first? And so we saw the baseline performance. And if we want to go in here and change any of the different factors, so for example, if we wanted to create a buffer inventory of 200 metric tons in Mombasa, we could enter that. And then basically it kind of trickles through in terms of the performance. And what we see in this case is it has a pretty negligible impact on supply chain cost. The only real difference in supply chain costs, it's a little bit more expensive because the total transportation cost is a little bit more expensive, and we've got some warehousing costs. But it has a pretty significant impact on the time, because now we're holding buffer inventory of the product much closer, in this case in Mombasa, and so we can respond to demand much more quickly, up to the point that we can satisfy all the demand from that buffer inventory. Andrea?
Just clarify what arrival means. This is handing off to the NGO partner that then...
So this is really arrival in country. So it would be arrival in the one main...
UNICEF controls the warehouse and they ship out to the local location.
Exactly. So there's a lot that's not included. So this would be arrival into Mombasa. And then from Mombasa, it might have to be distributed to some regional warehouses, and then even from the regional warehouses, then to the NGO partners.
Local NGOs would actually be responsible for ensuring it doesn't get stolen or it goes to the...
Right. I mean, that's managed by UNICEF to a certain extent, and then gets handed over to the NGOs. And that varies depending on the region and the country, how long that goes for. But yeah, this is just to within the country and isn't including the last bit of it. All right, so we could use this dynamic modeling tool to then start looking at what the impact is on performance of several of the different supply chain options that we might want to consider. And so one of the things we looked at is what happens if we establish a buffer inventory of a certain size at each of the different locations, in Mombasa, in Jebel Ali. Or we also looked at what happens if we had local buffer inventory. And what that would mean is, for example, if I had 300 metric tons of local buffer inventory, based on demand, if 50% of my demand was in Ethiopia, I'd assume I'd put 150 metric tons of buffer inventory in Ethiopia and spread the other 150 out across Kenya and Somalia. And what we see is, for Mombasa and Jebel Ali, there's some slight differences, but no significant differences in the performance. And we get pretty steady declines in what we're measuring here is the average delay across all three countries. So pretty consistent, steady declines up to the point where we get to somewhere on the order of 350 or 400 metric tons. And then the benefits beyond that start to decline. And essentially what's going on here is, if we say keep 200 metric tons of buffer inventory, what that means is maybe half of the demand that occurs during the transportation lead time can be met from the buffer inventory, but the other half can. And once we can essentially meet all of the demand from the buffer inventory, so that the buffer inventory isn't getting emptied on a regular basis, completely emptied, then there's no incremental benefit of increasing the size of that buffer inventory. The benefit to the local inventory does continue to increase up to the point where we've got enough in each of the different locations to satisfy demand in each of those different locations all the time. Now, obviously, the downside of having local buffer inventories is, one, you've got to decide how big they should be in each of the different locations, so it reduces your flexibility to some extent. We also have to worry, again, as Andrew was starting to allude to, about some security issues and how feasible is it really to maintain a buffer inventory in Somalia. And in many cases, that's just not really possible. Another thing we looked at is what would happen if we added a new local production facility. And so this is looking specifically about what would happen within Kenya if we added a local production facility in Kenya. And so if we did that with kind of an appropriate scale, the red line is indicating what happens to our supply chain cost. That comes down a little bit because we don't have to incur as much transportation, but the big benefit is in delay. By having a local production source, we can significantly reduce the amount of time it takes until we get supplied by that local producer. We looked at what happens with funding. And so the baseline is that we get funded as needed. Whenever demand occurs, we assume we've got the funding available to release that purchase order and start the production and shipment of that product. And so our baseline was about 6 weeks in terms of average delay. And then the blue bar is showing what happens if we have, I think it's a 400 metric ton warehouse in Mombasa, and green is Jebel Ali. Yeah.
Could you talk a little bit more maybe about their financing and budgeting process and how that impacted the project? It sounds like there's a lot of demand planning and financing.
There is, yeah. So an NGO partner, perhaps in conjunction with the Ministry of Health, will start to work with UNICEF and say, we want to, in this particular region, in these 3 towns, and we're going to have people located at those centers who are going to do the measurements to decide whether people are malnourished, and then or some other funding source. And they'll come up with the funding. And then once they get the funding, it's only at that point that they can place the order. Because the country office, the UNICEF country office, will obtain the money from the funding partner, and they've got to transfer that money to the supply division in Copenhagen before supply division will release the order to Nutriset. So the money has to be there so that supply division can make the payment. Yeah, Jeff?
So you're dealing with several different countries, several different government agencies, several different entities. How do you work out the exchange rate? Is it just the standard that all donations for international aid come in U.S. dollars, or do you have to worry about fluctuations in
Yeah, I mean, it turns out for purchasing pumping up from Nutriset, The LTA is in euros. So they've got a certain price in euros, so they actually have to translate things into euros, and that's what they're paying for. But yeah, at a certain point in time, if they're going to USAID, they've got to make the translation and say, if we need 1,000 cartons, and each carton costs 50 euros, so we need 50,000 euros, but we're going to USAID, so that means we need $82,000, or whatever it might be.
Okay, so the model could change based on the exchange rate.
Yeah, absolutely. And so, the model we did in dollars, and that is even though the payments are made to Nutriset in euros, dollars are what they're more used to thinking about. And so it is based on a specific exchange rate. And so within the model, there's a certain cost of, say, Plumpy Nut. And if the exchange rate were to change, you could go and alter that cost and see what the implications would be. Yeah.
Kind of jumping way back to
Yeah.
what we were talking about severely wasting and severely underweight. Did they ever go back and say, okay, if we attack this more at moderately underweight and provided for a shorter period but for more children, would that even out demand a little bit?
I mean, they definitely do look at that, and there's actually other products kind of in this product family that are more targeted towards moderately malnourished children, and so there are other programs that get involved in that. But yeah, absolutely. So what this is looking at is, here we're assuming that we get all the funding as needed. What really happens is the funding tends to be back-weighted towards the end of the year. And so we want to see what would be the impact on the performance of the supply chain if you did see funding that was back-weighted in those ways. And so depending on, if we take the kind of total annual need for funding within each of the countries and then spread that annual need based on a 20-20-20-40 quarterly basis. So 20% of the money in the first quarter, 20% in the second quarter, 20% in the third quarter, and 40% of the fourth quarter. What's the impact? And so we see that, again, the average delay goes up significantly because those orders at the beginning of the year aren't able to be completely filled until the money starts to trickle in later in the year. And so any benefits that we get from having buffer inventories are essentially completely eliminated once we move to the 20-20-20-40 allocation of funding availability. And if we get even more back-weighted, like 15-15-25-45 or 15-15-15-55, not unexpectedly, things get even worse. But this allowed them to see specifically what type of impact those sorts of unequal funding issues would have. And so in this case, it could cause the average delay to double or perhaps even more than double relative to what happens if we get funding on an as-needed basis. Another thing that we looked at is what happens if we have an unexpected demand surge. And so this is focusing within Ethiopia and assuming that we've got a demand spike in Ethiopia due to a nutrition crisis. And this demand spike causes demand at its peak to be 50% greater than the normal demand at that time of year. And from the start of the crisis, it takes 4 weeks to move kind of linearly up from normal demand to 50% above demand. We stay at 50% above demand for 5 weeks, and then it takes another 4 weeks for demand to linearly work its way back down to normal levels of demand. And so we look at what happens if we incur that sort of surge in demand, depending on how we choose to address it. So we can either continue to ship everything via surface means, or we can choose to satisfy the demand in this emergency period through air shipments. And so what we see is if we use surface treatments, then we get a slight increase in the average delay in weeks from about 5 weeks up to about 5.2 weeks. And there's an increase in cost. In essence, this increase in cost is really, since we're looking at total supply chain costs, this is just an increase in volume primarily. If we looked at it on a per metric ton basis, we wouldn't see much of an increase in cost in this situation. But because there's a surge in demand, we're buying more product, and so on an annual basis, it costs us more money to do that. If instead we decide to handle that surge in demand via air shipments for that period of time, and it represents a significant quantity of demand because demand's higher, we're getting much better performance. And so the overall average over the course of the years, we get even better performance. We're down to about 4 weeks in terms of the average delay. But there is a significant cost associated with that. So for the same volume of product, now we've increased the total cost by something on the order of $3 or $4 million. And so there's a heavy cost associated with it. And we also, using this model, could look at what happens if we use pure surface transportation for all of demand versus pure air transportation for all demand, or what happens if we use air transportation to get from, say, France to the warehouse, and then surface transportation from warehouse to each individual country, or any other combination. And so we can look at some of those issues as well. All right, so what are some of the things that we recommended? The first thing that we recommended was that we do implement a buffer stock. That seemed to be one of the easiest ways to address the significant issue that they're facing of significant delays from when an order was placed until when it was received. We suggested that they establish a buffer stock in the order of 300 to 400 metric tons, and we suggested that they put it in Jebel Ali, even though the performance was slightly worse in Jebel Ali versus Mombasa at that level. Again, we don't need to go much beyond this level because the benefits are really decreasing once we go beyond 400 metric tons. In Jebel Ali, just the physical infrastructure as well as the legal infrastructure for holding a buffer inventory was much better. In Mombasa, there were restrictions that you couldn't hold inventory if it was intended to eventually go out of the country for more than 45 days. And so that placed kind of severe restrictions on the workability of holding a buffer inventory in Mombasa and using that to satisfy demand in Ethiopia or demand in Somalia. Centralized buffer inventory provides greater flexibility as opposed to the localized buffer inventories, and just was more realistic in this setting. And what the model suggests is that in order to do this, we've got to come up with on the order of $1.5 million if it's 300 metric tons, or $2 million if it's 4 metric tons, in order to fund this buffer inventory. But it is important to recognize that that's not an annual increase in money that's needed, but just a one-time payment. Because once we've created that buffer inventory, then everything that takes place to replenish that buffer inventory is essentially the same cost as what it would have been if we were just operating in the traditional make-to-order environment. The way we use this buffer stock is essentially every single order that comes from the Horn of Africa would be satisfied from this buffer inventory. And then we'd issue a replenishment order back to Nutriset in order to replenish the stock that we have in our buffer inventory. Important thing there is we've got to make sure that the material that we're holding in that buffer inventory moves, that it rotates. It has a 24-month shelf life, but they did have situations where the product expired. You know, there's nothing worse than paying a lot of money for this life-saving product than have to throw it away because it's gone beyond that 24-month period. And so it's important that this buffer inventory not just sit there, but that it's active and that it gets replenished on a regular basis. And potentially, especially because it's located in Jebel Ali, that buffer inventory and that concept could be used to satisfy demand across, you know, not just other areas in Africa, but also demand in Asia as well. And the 300 to 400 metric tons was determined based on demand within Kenya, Ethiopia, and Somalia. If we wanted to use that buffer inventory to satisfy demand in other countries, we'd have to make it significantly larger. We suggested that they actively explore the ability to license a production facility in Kenya. And so local production had some significant benefits. Reduce the risks associated with relying on a single source. You know, what happens if something happens at this factory in France. Eliminates the lengthy transportation time to get from France to the Horn of Africa. It adds to our overall capacity. Capacity was tight in general, so anywhere where we can add capacity is going to ease this global crunch on our ETF products. And it also has some additional benefits in terms of economic self-sufficiency. We're creating jobs in Kenya. We're creating business in Kenya. And we're creating capabilities in Kenya, which has some benefits, and certainly to the folks that would be involved in making the investment. Obstacles associated with it, we've got to find a way to buy, you know, create this production capacity. There's patent restrictions, so we have to get licensure from Nutriset in order to do this. And we also have to worry about quality control. And in particular with peanuts, there really aren't issues with peanut allergies, but there are issues with certain toxins that can get into the peanuts and potentially cause serious problems.
Just a quick question on patent restrictions. Could you just clarify what's actually, because it's all commodity, I mean, it's just proteins.
Yeah.
Right? Can you come up with some alternatives?
It's
I'm not trying to run this
yeah, and again, I'm not a patent attorney because I don't really know all the details of this, but you know, the folks we were working with from Duke, that was a lot of what they specialized in, the global access to health and technology. And this is a big concern within the nutrition community because it's not just on the formulation, it's kind of on the use. It's pretty broad in terms of, you know, providing a vitamin-rich supplement for the treatment of malnutrition or something along those lines. So it is, I mean, it's a very contentious issue, as you can imagine. Yeah. Oh, they already have a production site in Ethiopia. So there already is a company that is manufacturing in Ethiopia. Increasing the capacity at that site would be an issue as well. But that was already established. Yeah, and there would clearly be benefits. There's more demand for product within Ethiopia than that facility has capacity. So increasing its capacity would be highly valuable. Had recommendations with respect to funding, and the big issue is that we've got multi-year funding protocols in place to allow the funding to be much smoother as we go about over time. We've got to look at funds for the buffer stock, and so that is an additional $1.5 to $2 million that they've got to try to find. Another issue with respect to funding was sometimes the funding would be available for purchasing the product, but there might be restrictions on that funding, which would mean you couldn't use it for the delivery of the product, either the transportation from France into the home country, or just as importantly, the delivery to the field within the country where it's being used. That often came from a separate funding source. And want to look at kind of more strategic approaches to funding and performance measurement within Kenya to try to get the Ministry of Health better bought into the process. And then just in general, there are benefits to sharing information and making information available about different funding partners and which projects they were funding so that people in general were more aware of that. Another recommendation had to do with improving the forecasting process. There are a lot of different tools that are used out in the field to assess what the need is for RUTF in different regions of different countries, and that was something that needed to be standardized. So again, clear articulation of the difference between need and demand, and developing recommendations on specific data standards to use. What are the demographic metrics that we're going to use, making sure that we're consistently applying it to the same age group, decide whether we're going to include young infants or not, allowing for different data within different districts of the country, determining incidence factors, and there's always this issue of incidence versus prevalence and making sure that you're consistent because they have different meanings within the health and nutrition community, and then accounting for the new reference standards. As those get put in place, what impact will that have on demand? And then also the ability to incorporate seasonal effects to make sure that we anticipate when demand is going to be stronger and can plan for it accordingly. Final recommendation had to do with data transparency. There's a lot of different systems that get used at different parts in the supply chain process. So automating data entry would reduce the number of manual errors. Making data more transparent was something that would be valuable. And one of the approaches that they were starting to use was using mobile phone technology or SMS technology as a way to keep track of what the inventory level is at different field warehouses and what the usage levels are out at those warehouses on a daily or weekly basis, so that information was much more available. And then the other issue is when there was an exception, and the target arrival date was changed, which happens so frequently, that would get changed by supply division in Copenhagen in the SAP system, but the communication of that change didn't happen throughout the rest of the supply chain. So supply division might know that an order which was originally supposed to be delivered on April 14th had been rescheduled for April 28th, but they wouldn't communicate that information, and so the NGO that was waiting for that shipment wouldn't know that it was 2 weeks late, and they wouldn't reallocate their resources accordingly. We went through and listed a bunch of KPIs, key performance indicators, that we suggested that they keep track of and measure, some of which they were already measuring, some of which to a certain extent they were measuring. The ones we suggested they focus on was overall lead time, so from the time you place an order at the country office until that gets delivered, and even further than most of what we were measuring, out in the field would be good. How many times we had delays in the target arrival dates, because those had to be changed. What's the overall landed cost per kilogram or per metric ton? Looking at product nutritional quality and safety, especially as we start licensing different production facilities. Are we delivering a consistent product that's meeting the nutritional needs and not creating any other health issues? And then coverage and efficacy from a nutritional perspective. Are we getting it out to all the people that need it? And is it actually solving the problem of malnutrition? Do we have people who, after going through the treatment protocol, don't come back? Information flow perspective, we want to look at customer service response time. So when there is an issue that somebody within the supply chain raises, in particular to UNICEF, how quickly are we responding to that? Exceptions handling, are we communicating clearly whenever an exception takes place to make sure that everybody that's affected by that exception is aware that it's happened. And then how accurate are we at forecasting? Let's make sure that we go back and see what the actual demand and usage was of the product and understand what the discrepancies were and what caused them. And so one final thing that I just wanted to kind of point out real quickly is I mentioned at the beginning that part of what UNICEF was looking for and the Global Nutrition Cluster was looking for was a description of how to do this type of analysis and information that they could share within their partnerships. And so UNICEF created a website, or a portion of their website, which is dedicated to this project. The Nutrition Articulation Project is the name of this project. And there's a final paper that's available on this UNICEF-based website. And there's also a link on the UNICEF website to the site that we created, which is this articulation guideline, which kind of walks through the approach that you'd want to take as you try to perform this type of analysis for any type of product. And so what we go through is, we kind of describe the different project steps, so project planning, selecting a framework, and we kind of describe some of the things that we went through to decide on the framework. Same thing for process mapping, data collection, data analysis, and coming up with the action plan and recommendations. And then we also have referenced, kind of cross-referenced those general descriptions of how to perform a project like this with specific examples from the RUTF study. And so if we want to see, all right, what did we do with respect to process mapping for product flow within RUTF? And we kind of talk about some of the issues that we thought about there as well. And the other thing that they wanted us to do was create a series of videos. And the videos are with respect to the dynamic model and how to use the dynamic model. So they kind of hooked us up. And all these videos are out here which talk about how the dynamic model can be used to assess buffer stock performance. And so they can go on to these videos, and it kind of basically just goes through the spreadsheet and talks about different parts of the spreadsheet. And kind of how if you wanted to see what would happen if you implemented a buffer inventory, how you do that within the dynamic model and what the impact would be of the performance of that. And so those you can follow along as well. And so that wraps it up. I know we're running pretty tight on time, but if anybody has any questions, I'll be here for a minute or two to answer questions. And I'm not sure if there's a class in this room or not.